Yeah, I say early one, but I know that's just stayed, so that's for good session.
Morning.
But you're really is looking at I mean, you say it's out there. Each other's there. Yeah. It's tiny. And then I say, no, I don't think you're out there. But you know, it's fine. You know, like it's like I'm pretty out for you. We just like go there and yeah, it's a good. No, I'll take it on Thursday.
All right. You guys can ask if you have any questions from any of the text review or the units limit packet. But you can also in the questions that problems that we haven't done are page 34 to 37 in the unit 1 limits packet, and also page 12 to 16 test review packet. So we can also go over problems on those pages. Okay. What do you guys want to? Questions do you guys have? I just create one. Have us try it. Okay, so the reason why this looks confusing is because we don't know what to do with that x minus 3, absolute value of x minus 3. So if we just think to the side here, what that absolute value of x minus 3 looks like. The graph looks something like this. There's a vertex at 3, 0. And the graph has a V-shaped graph. So think of an absolute value function as two different linear functions that just happens to have a starting and end point at 3 for the different functions. So if we can think of it this way, absolute value of x minus 3 is just, there's x minus 3. Without the absolute value, it's just positive slope, right? So positive slope is just going to be to the right of 3. That's talking about this segment here. And then you also have the negative version of x minus 3. That's the negative slope version of it. So negative parentheses x minus 3. And that is to the left of 3.
I don't know which one to put the,
It doesn't matter, yeah. As long both of the equal sign at 3, both of these will hit this point. So it doesn't matter. Which I just always choose. I choose the first one, but you can put it down here as well. You just don't want to put it in both. You have just one of the piecewise function to find the graph at 3. Okay. So are we good so far? So now that we have this denominator portion here, if I just put x minus 3 above, right? I'm just including that portion into this expression to make it, force it to look more like what we really want to look at for. Then we can clean this up a little bit and we can convince ourselves what this is, right? So x minus 3 over x minus 3 is just going to be what? 1. And then this is equal to what? Negative 1. So now it's a lot easier to read this, right? Limit as x approaches 3 from the right. From the right of 3 is this piecewise, and we're going from 4 to 3.1, 3.001. It's headed towards 1. So that's why our one-side limit there is just equal to 1. Yeah.
Is there ever a situation where the numerator and denominator would be different terms?
Not in this scenario. That would make it where we would need like a calculator to evaluate that. So the problem that you'll see, it will be something like this, where numerator and denominator is the same. You just have to clean it up first by rewriting the absolute value as piecewise function.
do you still have to do direct substitution to start the results? Or
Not, yeah, with these. Yeah, this doesn't quite work. Yeah, direct substitution for this doesn't quite work because you're getting 0 over 0, but it is obviously not a whole. It is a it's a jump discontinuity. Yeah, so absolute value doesn't quite fit that step of direct substitution for real numbers and compare degrees from infinity. Yeah, so we have a good point. Different set of rules for this. Yeah, what else do you want me to work with you?
We already reviewed the IBT or squeeze there.
No, we can go over some of that. Okay, here's a squeeze theorem problem. Morning. So squeeze theorem, you're always going to have 3 functions that the problem is going to already provide for you. It always has to provide with a certain relationship between 3 functions. Okay, so we want to find a limit as x approaches -3. So let's apply that limit to each of the statements. The middle is still unknown, but we can fill in G and F with specific expressions since we have that given to us. Okay, what do you think we can do next? Direct substitution into the expressions that we can work on. So -3 for x, 2 minus -3 squared. It's going to make this a positive, but that negative is still there. So 2 minus 9. -3 minus 4. Okay, do we have enough information to evaluate that middle unknown limit? Yes. So the numbers match. We know what that limit is. So we can say by squeeze theorem, but let's say instead of the result that you got this instead. What about now? Do we know what that middle limit is? No, we don't. It could be -7.9. It could be -6.1. It could be -7. These numbers have to match. If they don't match, then we need more information. We just don't have enough information. So we can say limit as x approaches -3 of h of x is inconclusive. Squeeze theorem does not apply. Okay, now see an IVT problem. I figure out a problem that could work. Let's see. All right, so let's say we have a function x squared plus 2x plus 1 on the interval from 1 to 3. Can we guarantee that there is a y value 14? The first thing that we need to establish is our function continuous? There's no issues here. If there was a denominator, then we would know that there's a vertical asymptote. If there's a vertical asymptote, we would have to make sure that the asymptote is not going to impact our domain, our interval. If an asymptote interfered with the interval, then we stop. But if the asymptote does not interfere with the interval, then we keep going. But in this case, this is a polynomial, no issues at all. Our function is continuous. So we have to first state that. And then make sure you include your interval as well. Next up, we have to consider the endpoints, the y values of the endpoints. The hope is that one y value will be lower than 14. The other y value is greater than 14. It doesn't have to be in that order. It could be larger to smaller, but we just need two endpoints on both sides of 14. So plug one in. Plug three in. Can we guarantee this 14 will be reached? Yes. You're starting at a y value of 4. There are no breaks, and you're ending at a y value of 16. You got to at least pass 14 at least once. So this is what we can say. We can say IVT, since f of 1 is equal to 4, and 4 is less than our target of 14, and 14 is between 4 and 16, and 16 is coming from f of 3, we can guarantee that f of c is equal to 14 somewhere on the interval from 1 to 3. I didn't design this problem well, because if I were to ask you for part B, find the value of c, then you would set these equations equal and solve for x. But this is not going to be factorable. But if it were, you would bring everything over to one side, factor, solve for x, and make sure that whatever x value you find, that it's going to have to sit between 1 and 3. That's the only part I don't quite have. But if I were to ask you to find c, I would have to make it factorable so that you can do it without a calculator.
There ever be a situation where there were a hole, and you would have to see if the C value is falling up or not?
Remember, if there's a, yes, yeah, that's true. Yeah, there could be a hole. And you got to see, but the thing is, I mean, it doesn't matter if it's a hole or asymptote. You're always just going to look in the denominator. So, I mean, it could be x squared. it doesn't matter if it's a whole or asymptote. You can just go ahead and find your discontinuity from your denominator. So it doesn't matter that the x squared, x plus 1 can cancel out. We know that these are the same issues here. This discontinuity. At x equals -1 and discontinuity at x equals 3. So.
And so it doesn't matter what.
Right. Yeah, you don't have to worry about is that a whole or asymptote. You know that's discontinuity. You can just jump directly to testing it against your interval. Yeah.
Then if there's any sort of discontinuity,
we stop. Right, IVT is done. Right. If it does not impact the domain, we keep going because these are the only places that there could be any discontinuity. You don't have to worry about any other x values. With these two problems, these are the only places where there are any issues all across for the entirety of the domain.
Yeah. For the first one, and then this value is like -1 for that, like do anything.
Right. So if you can get past this point, if the function is continuous and the endpoints are above and below, you're always going to find a C value. You may find an extraneous solution where one doesn't work and the other works, but we're never going to come across and find a C value and the only solution is outside the interval. Then, yeah, that will never be true, especially if you've already gone through, if you already confirmed this, then you got to find at least one solution. See if there's any problems that stood out to me. But yeah, if you guys have any.
BT, if it doesn't work, how should we phrase it? Like IDP.
You see. Yeah, let's say this was like 11 or something. Maybe you could say since f of 1. Yeah, maybe something like this. Since f14 is not between f of 1 and f of 3, IVT does not apply.
If the value from f of 3 ended up equaling f of c, so 14, would you just have to, in the IVC explanation, say less than or equal to?
Yeah, less than or equal to, yeah. Because, you can obviously tell that it does reach it at the endpoint, and that's good enough. Yeah, you just say like less than or equal to right here.
Thank you.
Let me see.
What did you ask me?
Basically, if like f of 3 ended up equaling like the end of the interval, so like if f of 3 ended up equaling 14, then you just have to do less than or equal to in that definition.
Yeah, if your endpoint lands at your target, then you can still make IVT pass. I want to create one here, see what you think about this one. Maybe a couple of tries. Okay, limit as x approaches m. X squared minus m squared all over x minus m. Okay, what's first? So how would you do the right substitution for this one?
M squared.
What'd you plug in?
I could plug M into X.
Yeah, plug, replace all the x's with m's. What do we get? Which means that
There's a hole.
there's a hole. That means we can remove the hole by factoring. What would that numerator factor to be? Next,
So that's minus
all right, final step,
M.
replace the remaining x with m. So our limit is just 2m. So sometimes students get thrown off because they're, sometimes we expect a number, but we get a constant, and constant sometimes throws us off, even though it's the exact same procedure. Okay, let's try this one. Okay, try this on your own first. Okay, what you guys get? Good, 4/3. Sometimes I see students do they look at that 2, they look at the 4, and they say, oh, my denominator has higher degree, this is going to be going to 0. But if we were to FOIL this out, we don't even have to FOIL everything out. We just know that if I can pair up the first 2 terms, that's enough to get to my highest degree, and then whatever the rest of the terms are going to be clearly less than 4. And then now the degrees match, make it 4/3. Another issue that students have is they would square the x, but forget about the 2. And they recognize the degrees are the same, but then forget that the 2 is getting impacted too. And so they would say 2/3 instead of 4/3. So, or they feel like the negative infinity is going to have an additional impact and they make it negative 4/3 or negative 2/3. But just know that if degrees are the same, it's just the ratio. The negative has no impact. It's going to be the same asymptote on both sides. Anybody have an answer? 0. Yeah. So we have 2 different families of functions. You got exponential and logs, but if we want to do comparative growth rates, we would like numerator over denominator. We can push that e to the negative x back down to the denominator. And the relationship is logs is slowest, radicals is next, polynomial, and exponential. If I have limit as x approaches infinity of a slower over a faster, my limit is always going to be 0. If I end up with a faster function, faster growing function over a slower growing function, then it's either plus or minus infinity, and then you're going to have to test 100 to see where it's headed. In this case, my exponential is growing faster than my logs. It's in the denominator. My fraction is getting smaller and smaller over time, so my limit is 0. Hey, Jason, how are you?
Did you have a good summer?
I did. How was yours?
It was awesome.
Yeah.
I was just coming in to ask you if you would be willing to write a college recommendation letter for me.
Yeah.
Yeah, I have this a hard copy of my brag.
Okay, sounds good. And then I'll look for your comment app.
Okay, yes,
request
I'll
as well.
send you invitation.
Thank you.
Thank you so much.
Have a good year.
You too.
See you.
I'll miss this call.
Let's see. Yeah, page 19 of your test review. Yeah, just again highlighting all the different types of problems that we've been going through. Yeah, if you're asking to find horizontal asymptotes with either radical in the numerator or denominator, you realize after you clean things up, your degrees are still the same. Just know that your asymptotes will be plus or minus, right? So in this case, for example 7 here, your asymptotes will be y equals plus or minus to the thing or square root of 5. Any other questions? Okay.
Not how lawyers also ask to questions mainly with.
Only if in this very special case, right? So the only types of problems that's going to have like a strange looking graph where you have different asymptotes on different sides of the graph.
Okay.
But only if there's like a radical above or below, and only if the degrees end up matching even after the radical for this one.
Okay.
Okay, so tomorrow, I'll do an abbreviated help session, 7:15 to 7:40. And then your test is